Kirchhoff law gives us the basic method for analyzing any complex electrical circuit. There is a different way of improving upon this method by using mesh current analysis or nodal voltage analysis. A mesh, also called loop, is simply a path to a circuit that start and end in the same place. For the purpose of mesh analysis, a mesh is a loop that does not enclose the other loop.
So this is the example of what is a mesh. Reminder that mesh is a closed loop path which has no smaller loops inside. I'm going to visualize it for you. So this is the first loop. This is the second loop. And this is the third loop. Now, okay, if I draw a loop like this, do you think this is considered as a mesh loop? No, because it still have a smaller loop inside.
Mesh can be clockwise or counterclockwise, and mesh current are circular current used for calculation. Mesh current are not the real current.
This is the procedure. First thing, you need to count the number of the mesh. Next thing is define mesh current on each mesh. For example, let the value be I1, I2 and I3, and use Kirchhoff voltage law or KVL on each mesh. And the last one is solve the equation. KVL is the algebraic sum of voltage around closed loop, and it must be zero. This is the first loop. And this is the last one. This is not the minus because the electric is run into the right position. Okay, and you use the calculator to solve the equation, and the answer that we get is
Let's go to the next problem. Here is another example. This figure is a little bit more complicated. The objective is to find the Vx at 3 ohm resistor. Then using KVL on each mesh. From T mesh we have T equations, plus we have another equation from Vx. You can solve by hand or use the calculator with system of equations support.
Supermesh or supermesh analysis is a better technique instead of using mesh analysis. to analyze such a complex electric circuit or network where two meshes have a current source as a common element. In supermesh circuit analysis technique, the current source is in the inner area of the supermesh. Therefore, we are able to reduce the number of meshes by one for each current source, which is present in the circuit.
Assume that this is a circuit. We're gonna have mesh 1 and mesh 2, and we use the concept of supermesh and combine this. So supermesh, we combine mesh 1 with mesh 2, and we're gonna use KVL rule on this. For this problem, we will see that the meshes involved with a current source here. So first we're gonna draw a mesh. So we will use the concept of supermesh here around the first mesh and the third mesh. Now we're gonna use KVL on supermesh first. And from the fact that this current source here involved with our first mesh and third mesh, the result we need to find Vx. Negative 3.55 volts.
Let's go to the next problem.
First, I define this one is first current, this one is second current, and this one is third current. The first current will equal to 40 ampere because this one is current source. So after that, we calculate the current number 2 by using KVL's law. After that, we calculate the third loop by using KVL's law again. This loop has voltage source. That means, so in I3 we can compare the current I1 and I3 with this source. That we can write the equation like this. After that, we can write the equation